Hi class, I'm going to show you a few examples from the quadratic formula. Before we do an example, I just want to show you the quadratic formula and show you where the values come from when we are solving these. Each example starts off as a trinomial, which I have here down at the bottom of the screen. The trinomial, there's two requirements before you can use the quadratic formula. The first requirement is that all of the terms of the trinomial, which are three terms, are on one side of the equal sign, making the other side equal to 0. Typically, people move everything over to the left side so that the right side equals 0, but that really doesn't matter. Next, the letters A, B, and C come from the coefficients of the trinomial. Once the second requirement is that the trinomial needs to be in descending order, where the highest exponent comes first, then the next lowest, then the next lowest. Once you have it in descending order and you have it equal to 0, the coefficients are A, B, and C, and then you plug those into the formula. Okay, our first example is m squared minus 5m minus 14 equals 0. The two requirements are already met. This problem, all three terms are on one side, and all three terms are in descending order. And so we can go ahead and say A equals 1, B equals negative 5, and C equals negative 14. I do encourage you to somewhere on your paper write out the values of A, B, and C so that you can easily look back at them as you're plugging them into the formula. Okay, so let's do that. Let's plug these into the formula. We have x equals, the formula is negative b. The b in this example happens to be negative, and so this is negative 5 plus or minus the square root. B squared, I'm going to put negative 5 in parentheses and then put the exponent, minus 4. I'm also going to put the value of A and the value of C in parentheses so that you know that we're multiplying these and not just combining them into one number. All of that over 2 times 1. The first thing we're going to focus on is simplifying the radical. I'm going to show you the same method that I showed you in class. If you look under the radical, right after the exponent of a 2, I want you to draw a vertical line, and then I want you to put a cross through it. That's going to represent addition, that we're going to add both of these sides together. So let me show you what I'm talking about. On the left side of that red cross, negative 5 squared is positive 25. On the right side, negative 4 times 1 is negative 4, and the negative 4 times negative 14 is 56. When you look at the cross, we can add 25 and 56 together, because if you allow this, and I'm going to highlight it in red, if you allow that minus sign to just be a negative 4, you can add both sides together instead of subtracting a negative number. Okay, I'm going to simplify it a little bit further. A negative 5 is a positive 5. Plus or minus, that represents that we'll have two answers. This is the square root of 81 over 2. We can simplify that a little bit further. This is 5 plus or minus 9 over 2. And then from here, I really encourage you, this is where our two answers are going to come from. I really encourage you to separate these two fractions, 5 plus 9 over 2, and then 5 minus 9 over 2. And the plus 9 and the minus 9, that came from the square root of 81. There's a positive 9 and a negative 9. Okay, the first fraction, if we add across the numerator, this is 14 halves, which is 7. The second fraction, if you add across the numerator, this is negative 4 halves, which is negative 2. And when you type your answer into WebAssign, you would just put x equals 7, comma, negative 2 in any order. This example is in descending order, and all three terms are on the same side of the equal sign. So we can go ahead and say A equals 2, B equals 2, and C equals negative 12. Once you have identified your A, B, and C, you can go ahead and start plugging into the formula. This is x equals negative 2 plus or minus 2 squared minus 4 times 2 times negative 12 all over 2 times 2. Okay, the next thing is I want you to draw this vertical line right after the exponent of a 2 and put a cross through it. That's going to represent addition. On the left side of that red cross, 2 squared is 4. on the right side, that subtract 4 is going to turn into a negative 4 times 2 is negative 8. Negative 8 times negative 12 is 96. Now I'm going to simplify it to negative 2 plus or minus 4 plus 96 is 100. And then 2 times 2 is 4. 100 is a perfect square number, so another way to write this is minus 2 plus or minus 10 over 4. Again, just like the previous problem, I recommend that you separate it into two fractions. You have negative 2 in the positive version of square root of 100 over 4, and then negative 2 minus 10 over the square root of 4. This one simplifies to 8 over 4, which is 2, and this is negative 12 over 4, which is negative 3. And so your two answers in any order is 2, negative 3. The problems are now going to be slightly harder. This is the first one that we have seen where all three terms are not on the same side and it's not in descending order. The first thing I want you to do is add 8x to both sides. And as you add the 8x, go ahead and put it in descending order. So it's 4x squared plus 8x minus 1 equals 0. Now we can say a is 4, b is 8, and c is negative 1. Okay, once we've determined our a, b, c, let's go ahead and plug it into the formula. This is minus 8 plus or minus 8 squared minus 4 times negative 1 all over 2 times 4. All right, right past the 8 squared, I want you to draw that vertical line and put a cross. 8 squared is 64. Negative 4 times 4 is negative 16. Negative 16 times negative 1 is positive 16. Okay, now we're ready to continue to simplify. This is negative 8 plus or minus 64 plus 16 is 80 over 2 times 4, which is 8. Now this is the first time that the number under our square root is not a perfect square number. So I'm going to come over here underneath the formula and make a factor tree of 80. Here's your factor tree. It has two pairs of 2's. So another way we're going to write this problem is negative 8 plus or minus 4 square roots of 5 over 8. We're almost done with the problem, but let me show you a special trick on simplifying these radicals. When you have three whole numbers that are on the outside of the radical, 2 will be in the numerator and 1 in the denominator, you can draw a triangle to connect them all. If each of them have a common factor, it has to be all three of them, it has to be triangle, then you can cancel out that common factor. So for example, negative 8, the 4, and the 8 all can be simplified by 4. So here, this would be a 2, this would be a 1, and this would be a 2. That looks like negative 2 plus or minus. It's not necessary to put that 1 in front of the square root of 5, so we'll just put square root of 5 over 2. And that's your final answer. Now to separate it for WebAssign, this is what you would do. Negative 2 minus the square root of 5 over 2, comma, negative 2 plus the square root of 5 over 2. So there are still two 2's in the final answer, but because there's not 3, because you can't draw that triangle, those 2's cannot be canceled. Okay, let's go ahead and try this one. The first thing that needs to happen is all three terms need to be on the same side of the equal sign. I'm going to keep the a out here in front of the x squared positive. So I want you to add 5x and the 2 to the other side. That would be x squared plus 5x plus 2 equals 0, making a 1, b 5, and c 2. So our formula is minus 5 plus or minus 5 squared minus 4 times 1 times 2 all over 2 times 1. Okay, next I'm going to draw the cross, which is addition. On the left side of the cross, 5 squared is 25. On the right side, negative 4 times 1 is negative 4, and then times 2 is negative 8. So this simplifies to negative 5 plus or minus 25 plus negative 8, or you can think of it as 25 minus 8 is 17 over 2. And that's your final answer because 17 is a prime number. It can't be simplified. WebAssign will ask you, you'll have to write it twice. So this would be negative 5 plus square root of 17 over 2, comma, negative 5 minus square root of 17 over 2. For this problem, we're going to work it a little differently. This time I want to keep the negative x squared where it's at and then just add the 4 over, because you can work with a negative a, and I just want to show you an example that you can do it. Once you add the 4 over and put it in descending order, you have a equals negative 1, b equals negative 2, and c equals 4. Now let's use the formula. We have x equals negative 2 plus or minus the square root of the negative 2 squared minus 4 times negative 1 times 4. All of that over 2 times negative 1. Here's where we're going to divide the radical. On the left side, negative 2 squared is 4. On the right side, negative 4 times negative 1 is positive 4 times another 4 is positive 16. To simplify this a little further, a negative negative 2 is 2 plus or minus the square root of 20 over negative 2. Here's the factor tree of the square root of 20. It does have two 2's. So another way to write this is 2 plus or minus 2 square roots of 5 over negative 2. Just like the other example, this time we can draw a triangle. It's a coincidence that they all happen to be a 2, but we can divide each of them by a 2, so this will be 1, 1, and 1, and that equals, that negative from the denominator can just come up front now, and so we have 1 plus or minus square root of 5. It's not necessary to put the 1 in front of the square root of 5, and it's not necessary to put the 1 in the denominator. And so the two answers is negative 1 plus square root of 5, comma, negative 1 minus square root of 5. This is the last example for this video, so if you have any questions, please let me know. Please send me an email or a text message, and I would love to help you understand this better. Have a great day.